Hello, this is Mr. Stansbury. I'm going to take you through the notes on tangent segments. At the end of this, you should be able to say, I can use tangent segments to solve problems. Okay, so first off, tangent segments. These are segments that connect to the circle at exactly one point, which is called the point of tangency. These segments are also perpendicular to the radius slash diameter at that point. Okay, so for example here's these are tangent segments here that are perpendicular to the radius. Okay, tangent segments from the same point, so in this case point y, if two tangents to the same circle share a point, then those tangent segments are congruent. So this is a tangent segment here, yz, and then y-axis is also a tangent segment. Since they share this point y, this segment here and this segment here have to be congruent. So in this case here, we've got this is 3x minus 4 and this is x plus 10. Find what x is. So we would just simply set these two things equal to each other. 3x minus 4 has to equal x plus 10, right? So let's subtract x from both sides. 2x minus 4 equals 10. Add 4. 2x equals 14, and we divide both sides by 2 and get x is 7. Okay? Okay. I just moved this problem over here to give us enough room for this piece down here. Inscribed circles. When a circle is inscribed inside a polygon, so here's a circle in a polygon. That's how I remember what inscribed means, is the circle is in, it's an inscribed circle. The circle's inside the polygon. The sides of the polygon are a tangent to the circle. So this is a tangent to the circle, this is a tangent to the circle, and this is a tangent to the circle. If you look at just part of this here, so like let's say if we look at just this section right here, this here is a tangent and this is a tangent, and they both share that same point, so that we know that these two segments here, if this is 8, this here also has to be 8. If these are both if this is 7, this over here has to be 7, right? And it says this whole thing is 10, so if this whole thing is 10 and this is 7, that means that this is going to have to be 3, and therefore this over here is going to have to be 3. So now we can find the perimeter of the whole thing by adding all these up. So that's going to be 8 plus 7 for one side. 3 plus 7 we already know is 10, and then 3 plus 8 is 11. So we add those all up to get 36, whatever the units are. So 36 units, oh, not squared, but just 36 units would be the perimeter. Okay? Okay. Okay, let's take a look at a couple examples here. Solve for x. Assume that lines which appear to be tangent are tangent. So this is tangent, that's tangent. Okay, so we know if this is tangent and this is tangent, they both share a point and they're both tangent to the circle, so that means that these two have to be equal. So we have -7 plus 4x has to equal 2x plus 15. I know that's hard to read. That's a plus and that's a plus. They're a little bit, that's a little bit difficult to read there. Okay, so let's try this out. So let's subtract 2x from both sides. We get -7 plus 2x equals 15. Add 7 to both sides, and 2x is what, 22? Divide by 2. So we get that x is 11. Okay? So same thing over here. We got they even give us the radius here is 21.9. That's 21.9. Since these both appear to be tangents and they are definitely sharing the circle, it's the same thing. And these are actually both pluses on here too. Just did not quite show up very well. Okay, that's hopefully a little bit better. So we know that 5 plus 13x is going to equal 14x plus 2. So let's do this. Let's subtract 13x from both sides. 5, oops, that's not supposed to be 5x, but just plain old 5. So 5 plus 13x equals 14x plus 2, so that's going to be 5 over here because that's gone, equals x plus 2. Subtract 2 from both sides, and we get 3 equals x on that one as well. All right, okay, got one last set of examples, but before we do that, let's do a quick video comedy break. Goats in a tree. Go figure. Okay, find the perimeter of each polygon. Okay, so since these are both tangent lines that share the same point, this is going to be the same as this over here, so that's 11. If this thing here is 16, whole thing is 16.7, subtract 11 from that, and we get 5.7 is what's left over. So this point right here, this section right here, is going to have to be 5.7, which makes this 5.7. And this is 7.1, and this is 7.1. So we can simply just add all those up together and call it good, right? So really we have, here's another way to look at it, 11 and 11 for these two right here, 7.1 and 7.1, and then we also have 5.7 and 5.7. So it's basically just each one of these doubled, right? So 22... sorry, that is 14.2, and that is 11.4. So we add those all up, and we get, what, 27.8 for our total perimeter on that one. Okay, and then this one over here, same idea. Let's see, this is 6.5, so this is 6.5. That's 8.9, so this part right here is 8.9. We know the whole thing is 16.1, so 16.1 minus 8.9 is going to be 7.2, right? Because we would do this. 0.2, 8 from 15 is 7. Yep, so that's 7.2 right here. So that makes this 7.2 right here as well. And if this whole thing is 19.2 minus 7.2, gives us that this part right here is 12, so this part right here has to also be 12. So we're just going to want to add up all the sides. We already know that this whole side is 19.2. This whole side is 16.1. This side here is going to be 6.5 plus 8.9, which is going to give us 0.4, add 9, 15.4, and then let's see, that's this one, and then this is 6.5 plus 12, which is going to give us 18.5, right? And then we just simply add all these up, 5 and 10 and another 0.2, 9, 10, 16, 21, 29, 2, 3, 4, 5, 6, 69.2 units, whatever those are. Okay? All right, that's all we have for tangent segments. If you have any further questions, please feel free to ask. Thanks.